Okay, this video looks at the volume of prisms. Now before we can do that, we must confirm that we can work out the area of 2D shapes. So first of all, we have a rectangle that measures 8 centimeters by 4 centimeters, and the area of this is 8 times 4, which is 32 centimeters squared. Now if this was the end of a rectangular prism, it would look like this. And if the depth of this was something like 6 centimeters, then we need to work out the the volume inside this rectangular prism. So in order to do this, we use what we've found out already. We know that the cross-sectional area, the bit in yellow of the rectangle, is 32 centimeters squared. And to find the volume, we take this 32 and we multiply it by the depth, in this case 6, giving us a total volume of 192 centimeters cubed, because it's volume. In this next example, we have a triangle with a base length of 10 meters and a perpendicular height of 8 meters. We wish to find the area inside the triangle first. Now remember, for a triangle, it's the base length times the perpendicular height, and then you must divide your answer by 2, which means that the area inside is 40 meters squared. Now, if this was the triangular end of a triangular prism, we now wish to find the space inside this prism. And if this had a length of 15 meters, then once again we would take the cross-sectional area and times it by this depth. So let's fill in those two missing parts. The cross-sectional area, the bit in yellow, is 40. The depth is 15, giving me a volume inside the shape of 600 meters cubed. In this final example, we have a trapezium. We know it's a trapezium because it's a quadrilateral, it's got 4 sides, and it's got one pair of parallel sides, which means it's a trapezium. Now the area for a trapezium is slightly more complex. In order to find this area that I've shaded in green, we must add the parallel sides and times by the perpendicular height, so the same sort of height that a triangle is multiplied by, and divide the answer by 2. So in this case, the area is 25 centimeters squared. Now, if I was to turn this into a prism, which is called a trapezoidal prism, because it's got a trapezium at the end, I would take the cross-sectional area of 25 centimeters squared and multiply it by its depth of 8, which would give me, in this case, a volume of 200 centimeters cubed.